Occasionally you may have an image where you want to soften an edge. As an example on the screen here, I've got this diagonal set of pixels, and to the top and left of that is red and below that is white. And maybe I'd rather have something more like what's shown to the right here, where it gradually fades from the red to white with a couple shades of pink in between. This also will have the effect of blurring a picture. So we go from a sharp edge of color to a series of transitions from the one color to the other. And the way we're going to do this, and that's what the letters here are for, if we're trying to calculate the color for the center pixel, in this case it's the darker shade of pink, we're going to get the red value from the 4 pixels around it. The one to the left, one to the right, one to the top, one to the bottom, and itself. So we're going to get 5 red values, add them together, divide by 5, so we're calculating an average intensity of red, and that will be the red value for the new position that we place. We do the same thing with green and with blue, and that average red, green, and blue value is what we use to make a new color for the center pixel here. If we do that for every pixel in the picture, in the example I have here to the left, we would end up with something like we have on the right, where we've got the solid red for most of it, but the edge of the red has transitioned into a dark pink, and then the first part of the white on the other side of that has transitioned into a lighter pink, and then we've got the solid white. So we have a couple diagonals of transitioning from solid red to solid white. And obviously this is a very simplistic example. An actual image would have lots of colors and lots of different edges. So let's look at what the code would look like to do that. We have a function defined here called blur, and it has an input parameter of a picture. So we're going to give it a picture. It's going to create a new picture with the blurring applied to it and return that to us at the end. So the very first thing we have to do is to create a duplicate of the picture. It may not be obvious why, but let me bring my example back up. So let's think about how this is working. To calculate this center pixel here, the color for it, we're looking above and to the left as well as right and below it. But if we've gone down this column and then this column and calculated new values and changed the pixels in our original picture, this pixel to the left will have already been changed to a different color when we come and try to calculate this one. So to be able to do the calculations with the original pixel's color, we need to transfer pixels from one picture to a new one. And so we will actually get the top, bottom, left, and right pixels from this picture. We will duplicate this picture to start with, and then we will get the center pixel from our new one, do the calculation, and set the color in the new picture. So let's take a look at the code again. We have a command called duplicate picture that just provides an easy way of creating just that, an exact duplicate of the original picture, both in terms of color, size, and shape. And so we assign that to a variable called blur picture. That's going to be the one we actually blur. The original picture that we get in we'll look at, but we won't make any changes to it. We set up our 4x and 4y loops using the range statement. Notice we're starting at 1 instead of 0, and we're also stopping 1 short of the width and 1 short of the height. Again, let's bring up the example and see why that is. If we're going to use the 4 pixels around the pixel we're calculating a value for, we cannot look above and to the left of this particular pixel. So we can't calculate a new value there. The first one we can calculate one for is right here, because that's got one above, below, left, and right. Similarly, we can't calculate a new value for along this right edge or along the bottom, because there would be nothing below it or to the right of it. So the perimeter rows and column of pixels in a picture will stay the original values. We cannot alter those, but anything inside of that is fair game. So we start at 1 instead of 0, and we go to 1 less than the width, 1 less than the height. We get a pixel from our blur picture at X and Y. Remember, this is going to be the center pixel. This will be the one that we ultimately change. And then we get the one to the left, right, top, and bottom from the original picture. Remember, the original picture won't change. To get the one to the left of our center, we're going to subtract 1 from X and use Y. Again, let's look at our example. If we're trying to calculate this one, the cell to the left is 1 less from an X standpoint, but the Y is the same value. As an example, let's look at the bottom one. It is the same X value, but it's 1 more Y value in terms of the coordinates. To get the one to the left, we're backing up on our X coordinate 1 and using Y. To get the one to the right, we're adding 1 to our X coordinate and using Y. To get the one above it, the top, we're using X, going backwards on the Y scale, -1. And to get the one at the bottom or below it, we're using X and then adding 1 to the Y to go downward. So at that point, we have the 5 pixels. The one we're trying to change, the center one, and the left, right, top, and bottom in relation to that center pixel. And then we've got 3 very long lines here. I'm going to scroll over so we can see all of the line, or at least most of it. We're calculating a new red value, a new green value, a new blue value by getting the red of the center pixel, the left one, the right one, the top one, the bottom one. So those 5 pixels, we're getting the red value, adding them together, and just off the edge of the screen, we've got an integer division by 5. We're doing an integer division because we can't set a red value to a real number. It has to be an integer. So we're forcing the result to be an integer as we divide by 5. We do exactly the same thing for the green values and then the blue values. Again, adding them together, dividing by 5. And then after we've got those 3 values calculated, we use make color with our new red, green, and blue values. That makes a color that we use in a set color of our center pixel. And remember, when we establish the value for center, we got a pixel from our blur picture. That's our duplicate that we're changing. All of the others came from the original picture. But because we created the duplicate picture to begin with, the fact that we're getting it from 2 different pictures is really as if we were getting it from the original, but it just saves us getting a pixel to do the set color at the end. Once we've gone through the loops and completed making the changes to all the pixels, then we're going to return the blur picture because that's something we created within this function, and so the only way to get it out is to do the return. Let's do a quick run and see how this affects a picture. We'll create a picture to play with. Let's choose temple. Then let's call blur and give it our picture variable, which I called pic. And remember that our blur function is returning a picture, so we need to receive that into a variable. So let's call it blurred. We're going to call our blur function, give it the original picture, and we will receive back a blurred picture. Press enter. It will take it a little while to run because for every pixel it has to look at 5 pixels. Okay, it's finished. Let's explore the original picture. And I will bring that in screen here in just a moment. I'm going to go ahead and explore our blurred picture. And I will bring them both in camera view. So here they are. Just a glance at them doesn't look much different. Maybe it looks a little fuzzier, a little blurrier down here in the green shrubby stuff in front of the temple, but the temple itself looks substantially the same. Let's use the zoom feature and go in at, say, 200%. So we'll make each of them twice as big and see if we can start to see differences. Again, it's not real obvious, but as we look at the picture on the left, the original, we'll see there's a fair amount of detail in the carvings. We look at the new one, it's just a little fuzzier. And let's in fact go down and look at the shrubs. And yes, we can see that there's much more clarity in the original picture than there is in the new one. An exercise I'll leave to the watcher is to consider what it would look like if we sent the picture through the blur function multiple times and kept taking our blurred version and making it blurrier. How many times would we have to do that before we'd notice a very significant change in the picture at the original resolution? So, again, to blur, grab the center pixel, grab the 4 around it, average the color values, make the new color, and set it. We'll see you in class.